Hi, everyone. I'm Cody T. I have over 5 years of experience tutoring students of a wide variety of ages, and today we'll be covering a calculus problem that was posted. So the question is as follows. For the function f prime of -1, if the function f of x is equal to 2x cubed minus 13x plus 7, approximate the value of f prime of a in the following ways. Round your answers to 4 decimal places. So before we begin, we have to first look and understand what the approximation means. This approximation is called a forward approximation, such that this value here goes to the right of the actual value f of a. So just a brief recap. When we have some line, some linear function y, we know that it's defined y is equal to mx plus b, where m is equal to the change in the vertical divided by the change in the x direction. In other words, if we have here point 2 and point 1, we would calculate m by looking at the change in y over the change in x, which would be equal to y2 minus y1 over x2 minus x1. The same concept here can be applied in calculus. So let's say we have a parabola. With this parabola, let's say that we have some value here at x2. Now, I want to calculate what the slope of the tangent line is at this point. How do I do that? Well, in order to approximate this value, we can select some arbitrary value and we can say, okay, I'm going to say this is value x0. Okay. The slope between these 2 points is defined the same way as before. So the slope of this value, m, is going to be, again, m is equal to f and the y value at x of 2 and the y value at x of 1 over x2 minus x1. The interesting thing is the value h represents some marginal gap between our original point A and our next point H. Therefore, this is very much similar to, in that fashion, where H is representative of the difference in the X values. So we could rewrite it as our slope is equal to f of x plus h minus f of x over h. So we'll apply this principle here. Now, the interesting thing about this function is that as we get closer and closer to the actual value of x2, let's say here, here, or even here, our value of h gets smaller and smaller because the difference between this point here and x2 is now very small. This helps us approximate the derivative as the value of h approaches 0. So here we're using a small value of h in order to help us approximate the value of f of -1. So let's plug in these values. We know that the value that we want is equal to f prime of -1, which means our x value is equal to -1. So we're going to do f of -1 plus 0.0001 minus f of -1 all over 0.0001. And this again is equal to our approximated value of f prime of -1. So let's plug in these values. We know that this top value is going to be the value 0.9999, again, minus f of -1 over this value here. So we can plug in this value of -0.9999 into our function here. So let's do that. We'll take our function and we'll say -0.9999 cubed times 2 minus 13 times -0.9999 plus 7. So let's get our calculator out and let's plug this in. For 2 times 0.9999 to the third power minus 13 times -0.9999 plus 7, we get a value of 17.9992. Okay, so now we know this value is equal to 17.9992. Now we need to plug in our value of f of -1. So f of -1 is going to be equal to the same thing, 2 times -1 cubed minus 13 times -1 plus 7. Let's do this calculation again. We have 2 times -1, which is -2, minus 13 minus 1, which is plus 13, and plus 7. So this comes out to a value of 18. Okay, so let's plug these values in again. Plugging these values in from above, we get 17.9992 minus 18 over 0.0001. This approximated value comes out to -7.0006. Okay, so this is using the forward approximation method to approximate the derivative of the value of -1 at this derivative. Now let's move on to part 2. So in part B, it says graph the function on a graphing calculator, then zoom in near the point until the graph appears straight. Pick 2 points and find the slope of the line you see. So looking here, this is the graph of 2x cubed minus 13x plus 7. Here I've chosen some arbitrary points to the left and to the right of the value of -1, or x equals -1. Using this, it says calculate the slope of the line that you see. So knowing that this top value is to the right of -1 and this bottom value is to the left of -1, we'll plug this in. So we'll say -0.978 minus -1.081. This is on the denominator, and the numerator is going to be the y value. So 17.843 minus 18.527. So this value, let's plug it into our calculators again. We now get 17.843 minus 18.527 all over negative 0.978 minus negative 1.081 comes out to a value of negative 6.6407. So as we can see here, the slope of the value approximated between these 2 points here, somewhere around here and here, is around 6.6, negative 6.6. And this is actually very close to the value that we got previously at negative 7.0006. That means that if we chose any point closer to -1, this value here would eventually approach that value of -7 that we got previously. So hopefully this answered this person's question, and I look forward to working with you in the future if you ever need my help. Thank you.